This week we are studying chapter 13, which is on waves and currents. So we're going to start out with a definition of waves. I'm going to do this in two flip lessons. This one today is over sections 1 and 2, and tomorrow's flip lesson will be over sections 3 and 4. And we will be doing, with the second part of today and tomorrow, a lab activity where you will circulate around and demonstrate some of these things. So as we talked about yesterday, the parts of a wave are the same whether it's an earthquake wave or a water wave or a sound wave or a light wave. So let's go over these, and you probably know these from 6th grade, but it's something that you will hear over and over again. You need to know how to label or draw these things on a diagram. So parts of a wave. And a wave, by the way, is the transfer of energy through water or the transfer of energy through a material. It doesn't have to be water. Okay, so let's go over the parts of a wave. Amplitude is the wave height. So if we draw just a nice wave like this, the amplitude is going to be the part from 0, which is rest or no energy, up to the highest part. That's the amplitude. And that's actually an indication of how much energy is in the wave. And that makes sense, right? Because if you drop a little rock in a pond or a fish tank or whatever, it makes a little ripple. If you drop a big rock, more energy, it makes a bigger wave, a bigger ripple. So that's amplitude or wave height. The crest and the trough, that's pretty easy. The crest is the highest point, right at the very top, and the trough is the lowest point. Pretty simple. Wavelength is exactly what it sounds like, the length of a wave, but here's the tricky part. The length of a wave is one complete cycle. So it's from here up, down to here. And honestly, in real life, the best way to measure it, it's easier if you measure it from crest to crest, because that's easier to find, in a picture or whatever, because you normally wouldn't have the graph here. So that's wavelength. And then finally, frequency is the number of waves per second. So this is a little trickier to see here. If we go like this and we said 1 second, 2 seconds, then the frequency of this wave is 1 wave per second. What would a wave with a higher frequency look like? A higher frequency would look like this. More waves per second. It does affect the wavelength. Yes. The frequency affects the wavelength. So the frequency, and when you talk about sound, a higher frequency is a higher pitch. A lower frequency is a lower pitch. What if the sound is louder? What's different then? Yeah, if it's louder, what's different is what's different is how high it is. So a louder wave would be taller, but if it was the same pitch, it'd be the same frequency. And it's easy to think about that, because think about a really loud noise. You can actually feel it, right? A really loud noise actually physically vibrates things. Okay, so that's part of the waves. Now, these, yesterday, probably what would have been most useful, hopefully, is if you did the key concept questions, which looked like this. So this is roughly what I'm going over, if you didn't get a chance to do those. So what happens in the ocean, waves waves start when there's a disturbance. If on the oceans, it might start from wind. In a pond or a lake or whatever, it might start if something gets dropped in. We know that tsunamis form from an underground earthquake or landslide. One of the other questions is, as a wave approaches, or what happens as the waves approach the shore, as a wave approaches shallower water, the same amount of energy is in a shallower ocean, and the water moves upward, and the wave appears to get bigger. I'm going to show you a picture of this on the next one. Let me just finish this page. Tsunami waves often start or travel through really deep oceans, so they don't look like much of a wave. And then when they come to the shore, they can be huge. So if we were to draw that, you've got a wave that starts way out here, maybe from an earthquake or something like that. And what's going to happen is the wave, it's the same amount of energy. As the wave comes in to shore and there's less room for it, the height of the wave gets bigger. So when the height of the wave is way up here, that's when the wave crests and crashes onto you. And if you've ever sat at a beach, you know, you see that. You see these little, they look just like tiny little ripples. And as they come in and it gets shallower, they crash up on you. And it's fun to just sit there all day and try to figure out which ones are going to hit you. Okay. And then after it crashes, you get the kind of riptide as the water gets sucked back. And yeah, so that's what happens as the waves come in. So I think we got those. And that's tsunami waves, waves and erosion. The other thing with waves and erosion is those waves are constantly pounding on the beach, which will wear away at rocks and driftwood and whatever else is there. Okay, the next really big thing, and this is going to tie into what we're talking about with the moon. So this part here, we're going to talk about it this week. It's a little bit confusing. This part is not in our lab, but we will talk about it a little bit next week as well. But one of the ocean motions, as it were, is tides. Now, living here in Colorado, tides are just, you know, kind of something we learn about. If you live near the ocean, you know a lot more about the tides because they affect your life on a daily basis. And maybe in that way they're a little easier to learn about. But, you know, all of us travel places, and you might travel someplace where you need to know about the tides. Plus, it's one of the ways the Earth affects, or the moon affects the Earth. So tides are mostly caused by the gravitational pull of the moon and the sun. So the moon, and this is greatly exaggerated, the moon is much smaller than the Earth, but it's really quite close. And the pull of gravity on the moon actually pulls the water out, and this is greatly exaggerated, but it's enough, and that's what's causing the tides. Here's the North Pole. And then, of course, the Earth is turning around on its axis. And so as the Earth turns, that sloshing area is the high tides. So judging by this picture, how many high tides are there each day, each 24-hour period? How many high tides? 2 high tides and 2 low tides. Because in any given day, let's see if I can do this. This will turn, oops, it didn't work. And I've got a couple, I'll link up on Edmodo, there's a couple really good animations, and there's a good Tim and Moby, because you can think about it and draw it and all that, but seeing the actual moving animations is really helpful in understanding what's happening. So the ocean is pulled, the Earth turns underneath the tidal bulge, and the high tides, you can't just say, oh, the high tides are going to be at 6 o'clock in the morning. Well, in one place it's going to be at 6 o'clock in the morning, and slightly down the coast it might be somewhere else, because the coast is not a big flat line. The high tide and low tide, 2 high and 2 low each day, roughly speaking. It does vary slightly by where you live. And the highest tides will occur at the full moon and the new moon. And we'll talk about that a little bit more next week. So actually, I've got some pictures right after this. Yeah, well, that's similar, right? So yes, and you can have the high tide, which is at the full moon, right? And one of the things they talk about, like during hurricane season and stuff, is when the high tide, or when a big storm, a hurricane or something like that, happens at the same time as the high tide, it makes it that much more water getting washed in. So yes, the sun affects the tides. The sun is much bigger, but much further away. And so because of that, it has a smaller effect. And so here's the moon, has a little M in it. And here's the sun, and here's the Earth, of course. And if the moon is here or here, you get a high tide. And again, we'll talk about this a little bit more next week. But this is the full moon because the sun shines on it and you can see the full moon. And this is the new moon because it's totally black and you don't see it. So when the sun and the moon are lined up in a straight line, then you get the higher tides. And we call those the spring tides. I don't know why they're called spring tides and neap tides. It's not that they happen in the spring, but just think of it as springing is jumping and leaping, and so it's got a big difference. And the neap tide, yeah. And so then the neap tides are going to happen when the moon is over here and the sun, or if the moon is over here. Whoops. Okay. Looks like there's some extra moons there. All right, we're just going to leave those moons there. I apparently did. Anyways, so what's happening there is the moon, which is pulling really strong, is pulling this way, and the sun, which is pulling a little bit, is pulling this way. And so you're still going to have a noticeable difference between high tide and low tide, but there's going to be less difference between the high tides and low tides. Okay, and this is straight from the textbook. And like I said, I will, I'll attach, and you can even just, do an internet search for spring tide, neap tides, or tide animations, but I'll attach some of those so you can see. So spring tide is the bigger difference between high tide and low tide. And so you can see the new moon. And then you get a neap tide when they're pulling in opposite directions. And then the full moon, which is another spring tide, and then the third quarter moon, which is another neap tide. And so you need to know those. No, nothing else. The other planets are far enough away that they don't have a gravitational pull. I know. Okay, so that is what you need to know for today. This is just another one of those worksheets if you want to quiz yourself on this. In terms of the greatest difference between high tide and low tide occurs when the moon is in which positions. The neap tide is where, and so this is a good just quiz yourself thing. It's a textbook worksheet that we didn't do. And there's those again. So that's it for today, and then tomorrow we will talk more about the currents.